Yeah, so hello everyone. So we'll just wait for some time, maybe 5 minutes, and then we'll start with. So okay, Abhishek. So we'll start by 8:10. We'll just wait for some other people to join, and then we'll start.
Okay, sir.
Okay. So till that time, I'll just let you know. For the final exam, I'll just give you an idea. So your exam, I guess, that is going to happen on 1st of September. So graph theory will be having a good chunk. That means 35 to 40% of the paper will be of graph theory. Like, yeah, 30% you can say will be of graph theory itself. So the questions uh, can be, the questions will be not that difficult, will not be very difficult to solve, like the algorithm of Bellman-Ford or Floyd-Warshall algorithm. It will be very simple problem. You can be asked to calculate the minimum cost spanning tree, or basic idea you'll be asked regarding Bellman-Ford or Floyd-Warshall, like the basic things, like in which the negative, if you have the negative weight, which of the algo you can use it. Okay, this type of a problem. A Dijkstra algorithm you can be asked, uh, because that is like the most simplest. Even though all the algo are simple, but for Floyd-Warshall and for Bellman-Ford, it can take some time to solve that. So that's why mostly Dijkstra, and then mostly from the 10th, from week 10 also. It will be asked, like you can be asked regarding the coloring or maximum independent set you have to calculate for the given graph. Okay, so this type of problem is very highly uh, has a good chance to be asked in the exam. So we will discuss. We have already discussed the concept in the last few sessions. Today we are going to just solve some of the problems from the some of the algorithm, like Crucial or Prism algorithm will be solving to calculate the minimum cost spanning tree, and that's the important portion. So I'm telling you the important. That means there's a very high chance that will be asked in your paper. Okay, to for the any given graph, you'll be asked to calculate the spanning tree that will be having that will cost minimum. Okay, you can use any method, and or even if any method has been asked, the answer will be same. Right, you already are aware of that thing, right? You're aware of that, right? Minimum cost spanning
Yes,
tree,
sir.
everyone is aware of that. Okay, yeah. So yeah, and then we'll solve some problem from the Dijkstra algorithm, Bellman, and then Warshall also. So yeah, so by 8:10 we'll start. Revision session has been already scheduled, I guess, from this Sunday, coming Sunday. Your first revision session will happen from starting week, like from week 1 to 4 or 6. And then you'll be having one session for calculus, and the whole one session for the graph theory. That will happen on 20. I don't remember the date, but the dates has been scheduled for the revision session. Okay, and today I guess is the last date for your graded assignment solution submission also. I hope you all have submitted the graded assignment also. So any further doubt that you have regarding exams or anything, you can ask.
Graded assignment and practice assignments are enough activities questions for interim.
Yeah, that is more than enough. For the graph theory you're asking, or whole paper?
Self for whole paper.
Yeah, that's more than enough. Yeah, if you have solved graded assignment, practice assignment very seriously, I don't think so you'll be missing any question in the paper. Like
And graph
most of the
theory
concept.
also.
What?
Graph theory also.
Yeah, graph theory also. And the
Yes, okay,
best
thank you.
way to practice is to practice at least 2, 3 previous term paper. Okay, at least two
Yes,
paper you practice in a given time, 1.5 hour. Okay, even though the
yes,
number of questions is almost 16 or 17, you'll be able to tackle the whole paper in 90 minutes.
so,
Yeah. So I told you the weight is 30 to 35% will be from the graph theory itself, and a good weight is from the calculus, and the remaining portion will be from week 1 to 6. Okay, so you can just think of 35, 35, or 35, 30, something like that.
Sir, calculus will come in exam.
Yeah, whole syllabus will come. Final exam, right?
Whole syllabus.
Whole syllabus will come.
Yes,
Yeah,
sir.
yeah. From week 1 to 12, week one to
So that
11.
class will be taken.
Calculus has been taught, right? Differentiation, integration, all those stuff.
Integration, yeah.
It has been taught, right? from week 7, 8, 9. It's there, right?
Sir.
Yes.
Yeah.
Yes,
Oh,
Only
yes,
those
sir.
questions. Yeah. Only those questions will be asked that has been taught. Like week,
Yes, sir. हाँ.
yeah. So those basic stuffs will be asked. To get an idea, you can just see the, I guess, quiz 2. Yeah, quiz 2, we're having some of the portions like differentiability, continuity, all those stuffs. And that will be asked again in the final paper also. And from the starting weeks also, some reflect the different type of relations, function, all those stuffs will also be asked in the paper. More we'll discuss in the revision session. We'll be having for a specific revision session. Okay, so let's solve some of the problem from this algorithm, and Abhishek will solve some questions. Yeah, Abhishek, are you there?
Yes, sir.
Okay. So any other doubt, any further doubt you have regarding the end term or anything? Any conceptual doubt you have? Graph theory
sir.
has been done, right? You are,
Yeah, so I wanted to ask something. In
yeah.
Prim's algorithm,
Which algo?
is it applicable? Prim's algorithm, is it applicable in case of negative weights?
Yeah.
Can you repeat that?
Prim's algorithm that is applicable in case of negative weights, negative weighted ages.
So where have been you asked regarding this, like negative edges for the spanning tree? Have you asked? Have you been asked in any of the graded assignment or anywhere?
No, actually, in the previous session of maths, someone was like the instructor was taking, so she said that it's okay in case of even negative weights. But when we like tried, we got different answer. Like so, like wanted to ask that only.
No, it will
She
be
said
applicable.
she'll handle it in the next lectures.
No, it will be applicable, but it has not been taught regarding that. Like you have been taught regarding the negative weight for where you have been asked to calculate the shortest path, right? In
Yeah.
like where you use Bellman-Ford or Warsaw method
Yeah.
algo, right? But for Prism or Kruskal, you just need like you have been taught in the graph. Like if you have been given a
So
simple graph and then you have been asked to calculate the minimum that will cost the minimum, right? So even though it is a negative, if you have a negative, it will work, but will not be asked. Okay.
okay.
Yeah.
Okay, that's okay. Thank you.
Actually, we have questions on negative weights in activity 11.9.
What? I couldn't hear you. Maybe.
Means there are questions which are based on the negative wedges in activity 11.9.
I'm not able to hear. Can you just write it in the chat box?
Am I audible now?
Yeah, you're audible, but a lot of noise, like a bit. Okay, can you just repeat it out again?
I'm writing the
Mhm. Abhishek, are you able to hear?
Sir, where do we get previous year previous year term paper?
Okay, what you can do is, have you joined any of the TA session?
Yes, sir, but I haven't have any PDF from that.
Okay, so what? So next, I guess in coming 2, 3 sessions, right, Abhishek?
Yes,
There
sir.
will be a discussion
Yes.
regarding the previous term paper, and that paper will be shared with you. Okay. So I guess next week itself, it will be scheduled.
So, sir, do we get every subject previous year term papers or only for maths? Hello?
Uh, for that, you can ask your TA if you can provide the papers, then that will be fine.
Okay. Okay, sir. Okay.
Yeah. Prim's algorithm is applicable.
Yeah, it is applicable, but I don't think so. There is any question, I guess.
Sir, there is one question in 11.9.
Oh, okay.
Activity 11.
Yeah, it will work. It will work. Yeah.
Okay.
Yeah, it will work, but there are like some cases where it won't work. So
There
we
are
do
some
not
cases.
know na.
Yeah,
Acha,
correct.
okay.
But that
Okay,
is
we
not.
don't know
Yeah, yeah.
whether to apply. Yeah, go on.
ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಮಾಡಿ ನೋಟ್ಸ್ எடுக்கட்டு
Okay, okay, Abhishek,
Yes.
we can start now. We'll solve some. Yeah, we can start.
கொஞ்சம் குடிக்க தண்ணில
Uh, Shiva, can you mute yourself? Are you asking any doubt? Okay, start. Is my screen is visible to you guys? Hello.
Yes, sir. Visual.
Yes, sir.
Okay, so first of all, we will discuss about Dijkstra algorithm. So, what is Dijkstra algorithm? Dijkstra algorithm is used to find the shortest path from the source vertex, and it is applicable for only positive edge weights. Okay. Any doubt in Dijkstra algorithm? Anybody having doubt in Dijkstra algorithm? Okay, so we can solve some problems. So yeah, this is the first. This is the problem. This is an undirected graph. Undirected weighted graph. This is and now we have follow question. Is it visible to you guys?
Yes.
So this is the first question we have. An undirected weighted graph G as shown in figure, as shown in below. This is an undirected weighted graph. So you have to find the set of all the positive integer values of x as that if you use Dijkstra algorithm, the length of the shortest path from the vertex A to the vertex J is less than 30. Okay. So you have to find. So you know that Dijkstra algorithm is applicable only for positive weighted graph, right? Means it's not applicable for negative weighted graph. Okay. So use that concept and you will able to find, you will able to solve this question. Try this question. Okay. So you have to find the value of this x, this value x, so that the distance from the source vertex, this is your source vertex A, distance from the source vertex to this vertex J, this is an end, will be less than 13. Remember, less than 13. Try this question and let me see how we will solve this.
Can somebody tell me how will you approach this question? If you have to find the shortest, what has been asked? Okay, so the length of the shortest path from the vertex, that is the source has been mentioned here, from A to J. Okay. Okay. So the information has been given. The length for the shortest path from A to J has been given, that is less than 13. And then you have to find the value of X. Okay, so somebody is saying B. So how did you approach? Can you tell me the approach? How will you start and solve these questions? So the first step should be what? Are you guys able to hear me?
Yes,
Yes.
Any of you want to answer this? Okay, yeah. So whoever has said done what, yeah. So you are correct. So we can just first remove BE, like. Okay,
this
so
point,
he's saying
this
A.
vertex.
Correct. Yeah. So whoever has answered, I guess one people. So after removing X, you can apply the Dijkstra algorithm and then check what is the length that you are getting, or the shortest path that you are getting from A to J. Okay, so many people are saying option B. I guess option B is correct option.
Should I solve this problem?
Yeah. You can go ahead, Abhishek.
So first of all, we will remove this vertex. This vertex we will remove. This vertex BE. Then we will have this. Okay. So first of all, we'll start with A. So our source vertex will be A naught. Means the distance, but the shortest part from the source vertex to itself is 0, and rest of all the vertex will be infinity. And we will remove this BE. So now we will find the shortest part, means for the all the vertex. So shortest part from A to D, what is the shortest part? It will be 1 for this, and for this it will be 2, right? And now we will find the shortest part from B to C. Because of a we will Dijkstra's algorithm is used to find the shortest path from the source vertex to all the vertex. So we will find the shortest path. Tell me what about this vertex? What is the shortest path? This will be till here it is 2, and 2 plus 4 is 6, right? Okay. What about the shortest part of H? Or you can go by this way. You can use, if you go by this way.
7 will be the shortest path from C to
Yeah.
H.
Yeah, because if you go, there are two ways to go to 7, go to H. That is, this is first way and this is second way. Okay. So if you use this way, you will get 3 plus 4. 3 plus 4 is 7. And if you use this way, it will be the 3 plus, sorry, it will be 8, right? So you will use the shortest path. Shortest path is 7. So you will use this way. So it is, this is 7. So we have used this way, and then this way. And what is the shortest path of E? 3 plus 6. 6 plus 3, that is 9. Okay.
H should be 13, not 7.
Yeah.
Most empire can you move? Okay. So the shortest part of, so shortest part from C to E, which is 6 plus 3, right? 6 plus 3, which is 9. And from 9 to 4, we will have to take, it will be 13. And now 13 to H to J, that is, this is the shortest path. This is only one way. So it will be what? 14. But you have to find, but you have to use, means here we have to use that, you have to use this way. You have to find this way. So what will be, it is given that the shortest part, the path from A to J is what? Less than
14.
13, right? In the question itself it is given. See, it should be less than 13. So you have to choose the value of x so that it will be less than 13, less than 13.
There is a mistake. From G, if you are not able to see this, from 9 you go to the G, it will be 10. From there it will be 12. So H should be, instead of 13, 12 now. You don't have to go directly.
It will be 4, 6, and use this way. It will be 9, and 9 and 4. Okay. You can use this way also. Okay. Yeah. There are two ways. From E, there are two ways.
You're looking for sharps, right?
Yeah. E, from there are two ways. This is 9, it's correct. From there are two ways. That is this way. If you see this way, if you are able to see this way, if you choose this way, it will give 4. But if you choose this way, it will give 3, right? But we have to choose the shortest part. That's why we will choose this way. So it will be 9 plus 1, 10. And from this, we will take 10 plus 2, 12. And this is 13. And we know that we have from A to J, we will got that it will be 13. But we have to choose the number which is less than 13, right? We have to choose the number which is less than 13. So we should have used that is, but from here we will get that A to J is 13. It's equal to 13, but we have to choose the number less than 13. So which way you should use? You have to use this one and directly this one, because we have to use this x, and then this way. So see how many vertices are there. Let's find. From A to B, it is 2 plus x plus what? From E to
+1,
plus 1, right? Plus 1
+2,
plus
plus
2 plus
1.
1 should be less than 13.
Yeah.
So what are the values we will get? X should be less than 13 minus 6, right? So x should be less than 7. So what are the values of x?
So
One.
X value would be 5, I think, by the Pythagoras theorem.
We are not using Pythagoras theorem here. We are just adding the values. This is not a triangle type of things. Okay, this is not a triangle. Let me increase this. Okay, so x, the value of x should be less than 13. But we know that in Dijkstra algorithm, we can't use the negative values, right? We will always use the positive values. So what are the possible values of x?
1, 2,
1,
3,
2,
4, 5, 6.
3, 4, 5, and 6. Okay. So these are the possible values of x. So the option B is correct. Anybody having doubt in this?
No, sir.
No, sir.
Okay. Can we go ahead?
Yes.
Yes, sir.
So yeah, this is the problem. We have this. This is the second problem. So a company has a branch. So a company has a branch in each of the 5 cities. That is C0. Okay. So this is the branch. C1, C2, C0, C1, C2, C3, C4. The fare for a direct flight from CI to CJ is given by this entries. This is an adjacency matrix. If you remember, this is an adjacency matrix, and this denotes what this denotes. This values, this weight of each, right? Each weight. So you have to draw a graph of this adjacency matrix, and you have to find if C travels by the cheapest route as possible. So you have to find the route from C0 to CJ. So what is the route? If C travel by the cheapest route, then what is the total fare? Okay, you have to find the total fare. You have to find the fare from C0 to CJ. So yeah, try this question. First of all, you have to draw the graph of it. Those who are not able to understand the question, you can ask me. I'm waiting for a few minutes so that you can see.
So everybody understood this question?
Yes, sir.
Okay. So you just have to use the Dijkstra here also. Okay. From C0 to C3, that employee wants to move. Okay, from that C0 city to C3 city. Okay, so your source can be C0 and you have to go to C3. Okay, so first, what you can do from the adjacency, you can draw the graph. Okay, and then use the Dijkstra algorithm. You just have to calculate the weight. So I guess whatever the weight that you are getting, if you are getting some 10, you just have to write 10K, like 10K.
Are you able to draw the graph? If you are finding difficulties in drawing graph,
This would be C0 to C4.
sorry, most are trying to say that. Okay. Start. So first of all, you know
It is
that.
not C0, it is C1.
Yes, sorry. Okay. Okay, let's draw the graph. How to draw the graph? Put any vertex C down here and C1, C2, C3, C1, C2, C3, C4. These are the vertices. And now check whether, so C0 to C0 is 0, right? C0 to C0 is 0. Now check from C0 to C2, is there any weight? Yeah, 2. 2 is there, means C0 to C1, there is a weight which is 2. From C0 to C2, there is a weight that is infinity. Means there is no weight, right? No edge, means no vertex. From C1 to C0 to C2. So from C0 to C3, infinity again. From C0 to C4, we have an edge that is 4. From C1 to C2, C1 to C0, sorry, C1 to C0, there is an edge that is 2. The weight of the edge is 2. From C1 to C1, that's 0. C1 to C2, there is an edge that is 3. C1 to C3, there is an edge that is 9. C1 to C4, there is no edge, that is there is an edge, means there is no edge. Infinity means no edge. From C2 to C0, there is no edge. From C2 to C3, C2 to C1, sorry, C2 to C1, there is an edge that is 3. We have already done. C2 to C2 0, C2 to C3, C2 to C3, there is an edge that is 1. C2 to C4, there is an edge that is 5, right? And yeah, done with C2. Then check for the C3. From C3 to C0, there is no edge. From C3 to C1, there is an edge that is 9. C3 to C1, there is an edge. Yeah, we have already done with this edge. C3 to C2, C3 to C2, 1. C3 to C3, 0. Okay. C3 to C4, there is an edge that is 10. Okay, so we have almost drawn the graph. So 5, 5, yeah, done. So this is the graph we got. If you this is 4, this is 2, this is 3, 1, 10, this is 5, this Okay, all the ages are there, right? So now we have to find the so the what is your source? Then what is your source? Tell me. Anybody have solved? Let me check.
Note, sir.
Yes, we go C0 to C1.
Yeah, our source is C dot, and we want to go to
C1.
C3.
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 This vertex, right? Okay, let's check the what is the weight. What is the weight? So, so from C0 to C1, what is the weight?
2.
Okay, from C0 to C2, this is one way. This is one way. This is one way.
Yeah.
I am asking each one.
And C4, sir. C0 to C2, C4.
Okay, okay, let's check for the C4 first. So from C0 to C4, what is the weight?
4.
4, sir.
From C0 to so what is the 8 from C0 to C2? Are you able to find any age? We
Yes,
can
sir.
use this way, right?
Yeah.
That is, what is the way
6.
first? It will be shortest path is 5, right?
Yeah.
And what is from C2 to C3?
Is
1.
1, 6.
6, right? This is the minimum cost. So from C0 we will get from C0 to C3 we will get age as 6. So we will write, if you get 10, then we will write 10K. If you get 6, then you will write 6K, right? So this is your answer. And what is the path? Path is this one. This is the path we have chosen. Okay. Anybody having doubt in this?
No, sir.
If you have any doubt, you can ask me. Okay, so let's move on to the next question. So yeah, you have to find. So a company branches, if an inspection team member want to inspect all the branches of the company, starting from C0 to ending at C3, visiting each branches exactly once, then which road should the should he choose in order to pay the minimum fare? Okay, try this question. The same question. This is the same question. Ten, 4, 5. So the company wants from the source, the company wants the wage rate of all the branches. So which path he should choose? Here it is 0. Here it is 2. We have done this. 5, and then it is 6. And what is the age weight of this path? X 6 to this one is 10. So which path the company should choose? Because you have to visit one vertex one time. So you have to choose one path which has minimum edge weight, right? You choose any path. Or how many paths are there? Guys, start solving this, or are you guys trying this question? Should I wait for a few minutes? You have to visit all the vertex one time only. Okay, I have to find the path, the shortest path, means the minimum length of it. Okay, let me see. So, okay, suppose if you choose this path, this circle path. So, what is the weight of this path? Okay, let me. So we will find a minimum cost, a minimum paths. Okay. So first of all, let's choose. From this is the minimum, this is the minimum, and from there we can choose this one. And after that, there are two ways to visit 4. Okay. This, this one, and okay. See this part. This one, and use this part, and this part. We are able to cover all the vertices, right? So what is the weight of this path? Let's choose. Let's tell me the weight of this path.
20, sir.
Weight of this part is 2 plus 3 plus but 5, 5, right? 2, 3. We are not choosing this part because if you choose one, there is you have to choose 10, right? Okay, I will tell you why we are not choosing.
Sir,
Remove this one.
question
Suppose,
is why you have taken 5, sir?
okay.
Sir, it should be 1.
Yes, sir.
Okay, I will tell you. So suppose, okay, let's choose this part. If you say that choose this one, this one, this one. Okay, it's fine. Now,
Yes.
so tell me what is the weight? 2, 3,
1.
1 plus What?
You can't choose this.
10. Yeah.
Wait a minute. You can't choose this. It will end up in 4. The problem says you're going to land up on 3. End should be 3.
Okay. Yeah. Yeah, end should be 3. Yes, yes. We can't choose this because our ending path will be 3, right? See, the question says that the ending path will be 3. We have to end till 3. So from C2, we can't directly go to C3. We have to use this path. Okay.
Okay.
And there is another way. If you go to C4 and then C2 and then C1 and then again C3, you can use this path also. So tell me the weight of this path. First of all, C2, 2 plus 3, and then this is 5. This path is 5 plus this path. This vertex is 10. So what is the weight? 20. What about this path? C2 to C4 is 4 plus C4 to C2, which is 5, right? From C2 to C1 is 3, and from C1 to C3 is 9. So what is the weight? 21. So which path you should choose? This one, right? Because it has less weight. See, is there any another possibilities are there? You are able to
C4
find.
to sir, C4 to C0, C1, C2, C3, not possible.
Which path? Sorry.
C4 to C0.
You have to start with C0, right? You're starting.
Okay, sir.
The starting and ending is also already mentioned here. The starting from C0 and the ending is C3.
Okay, sir.
Okay. So the path will be C0 to C1 and then C1 to C2 and then C4 then C3.
Sir,
So
the
you can
path
change
will
them.
sir, path will be C0, C1, C2, C3. We can tell, no?
C3,
C0,
C0,
C1, C2,
C4,
C2, C3.
C3 you can't choose. C3 you have to choose. This is your ending. This is your start. And this is your end.
Yeah. C0, C1, from C1, C2, C3 we can go, no?
Yes, but we will be missing out C4.
Yeah, we have to choose.
We have to cover all points.
All the vertices, right? You have to visit each vertices. Okay. So yeah, let's move. So now Bellman-Ford algorithm. So this algorithm is find the shortest path from vertex to other vertex. So which has negative as well as positive edge weight. Okay. Same thing, but here we have negative as well as positive edge. So try this problem. So the first question here. So you have to find which of the following can be the possible values of x. Bellman-Ford algorithm is not applicable in negative weight cycle. So remember this. This is a directed graph. This is a directed graph. So remember this thing. That's the concept in this problem. Cycle. Okay. Weight cycle. So if you see that this one is creating a cycle, this one is creating a cycle. So this one is creating a cycle, so you have to find the values of x so that The cycle should be non-negative. Enough hits. That's fine.
So could you explain the non-negative cycle?
Non-negative cycle means suppose if you have cycle like this. So this is a cycle, right? This is a cycle. And so suppose the weight of this graph is 2, 3, and minus 10. So if you add all this cycle, if you add all this, what will be the overall value of this cycle?
5.
Minus 10 plus 5. Minus 5, right?
Minus 5.
So this is a negative weight cycle. Okay.
Yes, sir.
The overall weight should be non-negative. Remember this, if you are creating a cycle, if you have a cycle, the overall weight will be non.
Sir,
Yeah.
sir, could you please explain what does this negative 5 represent? Means negative weight cycle. I understand the positive, but what does negative weight cycle?
I've already explained here. See that the vertex. So this is a cycle. If you are getting, if you are able to see, this is a cycle. You are asking for the negative y. What is negative weight cycle, right?
Yes, sir. Yes, sir. Yes, sir.
So if you, this is the weight of the vertex AC, CB, and BC. This is the weight of the vertex. So what is the weight? Okay, let's add all the weight. So this is creating a cycle. Let's add all the weight. So what will be the weight? 2 plus 3 plus. If you add all the weight, 2 plus 3 plus minus 10, right?
Minus 10. Yes.
So what is the overall weight?
Minus 5.
Minus 5. This is negative. So if this value is negative, if the overall weight is negative, this is a negative weight. Okay.
Yes, sir.
In this problem, you will see that there is only one cycle. This one is not creating any cycle because this arrow is here and this was opposing arrow, right? So this one is not
Sir.
creating cycle. This one is also not creating cycle. So there is one cycle. This one, and this one.
Yes, sir. Got it.
So which of the following? You can choose any values of x so that the value of this cycle shouldn't be negative. So okay, let's me solve this problem. Let me see. Okay, let me solve this. So the value will be okay. Tell me the cycle. That is 3 plus 4. Are you able to see the cycle?
Yes,
Yes,
sir.
sir.
3 plus 4 plus x should be greater than 0, right? That means x should be greater than minus 7. So what are the values of x? X belongs to
Minus 17.
minus 7 to. So which of the following option is correct?
Sir, I have a question, sir.
Yeah.
Sir, yes, me too.
Sir, in question, how can we identify no negative weight cycle? Can you please explain this one? In exam hall, by chance, if I get confused, then how can I identify to find
So
no weight cycle?
no negative weight cycle. So you have to see so this is a directed graph. If you are able to see, this is a directed graph. So this has direction this side and this has direction this side. So what is the what is the cycle? What is the definition of cycle, first of all? So if you are making this cycle, so suppose this triangle, I am making this rectangle as a cycle. So what are the values of the value of this? This is going this way and this way. And then this one is opposing this way. So there is two head, right? There is two head. Are you able to see? There is two head. If there is two head, then we can't say this one will form a cycle. Cycle will form either it will be a head and it will be a tail. Head or tail condition.
Yes, sir.
So there are two heads, so we can't say this is a cycle. Similarly for this one is head and this one is tail. This one is head and this one is tail. So you will see that this will create a cycle. So you have to see the graph. In a directed graph, you have to see that it is forming a cycle or not. So in Bellman-Ford, there should be no negative weight cycle. And I have already explained why this is one is
Means
called as.
it will be our condition. Our first condition will be that there will be no negative cycle in
Yeah.
Bellman-Ford.
Yeah.
Okay. Sir, while you were explaining example, you said that negative weight cycle, that 2 plus 3, this one.
Yeah, this one. So are you able to get this one?
Yes, sir. Because it is negative.
Yeah.
Our integer is negative, so it will be negative weight.
Okay. So shall we move on to the next question?
Yes, sir.
Sir, I just want to ask one thing.
Yeah.
Sir, why can't we choose here -6 to infinity?
-6 to infinity.
Yes, sir.
Suppose if you put in the place of x, if you put values, what will be -6? Less than -6, minus 5.5. Okay, if you choose -6, will there be any issue if you choose -6?
Because not to form to the
7
cycle.
plus -6 is gives 1, right?
Yes, sir.
So we can this you have to find the values which is the possible values of x. The question is asking the possible values of x. If the question asks you which of the following can be the value of x, the possibility condition is not there, then you can choose 6 to infinity. But in the question that less than 6 is also possible, right?
Yes, sir.
Okay, that's why we are choosing from -7 to infinity.
Okay, sir.
Okay. So this is the problem. This is the first problem from the Bellman-Ford algorithm. Here you have to make a adjacency matrix.
Sir, but when we put x is equal to 7, then it will.
Yeah, that's why it's a open bracket.
If we take -7, then it will become a positive triangle.
Okay.
Weight of positive triangle, but the weight will. Okay, -7.
It is a open bracket, right? It is
Yes.
a open bracket.
Yes, sir, yes.
Okay. -7 and -6. We are choosing values from here. You said that if you want to choose values from here, this side minus. But we are choosing values from here. This is also possible. This area -6 to infinity is also possible. But what about if the question asks like minus 6.5? This one is also possible. Okay, are you able to get it?
Yes, sir, yes.
It's an open bracket. The -7 is not possible. Means if you say that it will be a -7.
We have to check in the triangle If
Yeah.
there is a formation of a triangle, and we have to find one of the edges, then we have to check that what will be the sum of all the edges. It should
Yeah,
be
it
that,
should be a, first of all, it should form a cycle.
yes. First
It
and
can be a triangle, it can be a square. If someone says that, okay, let me change the value.
Sir,
Let
if option A is in square
If
bracket,
x
then
is not there here the value is 5. And suppose here this is x. Then what you will do? This is forming a cycle if you see. This is square. The arrow is head tail condition. So this is forming a cycle, right? This one is also forming a cycle. This
No, sir, it
rectangle.
isn't forming a cycle. From 1 when we'll go to 3, 3 is getting both the heads. No tail is connected with 3.
Okay, sorry.
sir, if
It's
option
not
A has a square bracket, it can possible square bracket -6 to infinity.
Sorry, square
Yeah,
bracket
yeah,
-6 to infinity.
yeah.
No,
Yes, sir.
it is not possible.
Why, sir?
You have to, it is a possible values, but you have to choose the, find the possible, can is there, na?
All the possible
Can be,
values.
all the possible values.
We need all the values. If we are considering from 6, -6, then the values from -7 to -6 is left over. But
Yeah,
that is not
because
what we want. We want to,
-6.5 is also
yes,
possible value.
we want to include all the
Sir.
values from -7 to infinity. It's basic inequality representation on this real number line.
Okay, yes, sir, got it.
Any doubt? Anybody having doubt in this?
No, sir.
No, it's clear.
So we can move on to the next question. So yeah, you have to find, so consider this is a graph as shown in below. Perform the Bellman-Ford algorithm. Suppose the source vertex is 0. So this is our source. Source vertex is 0. And we need to perform a Bellman-Ford algorithm up to 3 iteration. 3 iteration means, you know how to perform Bellman-Ford algorithm?
Yes, sir. Yeah. This iteration part is not clear to me. I'm having little bit difficulty in this.
Okay, those who have cleared with this, you can try and then I will explain.
Okay, one second. So for Bellman-Ford, can you tell me what's the difference like between the Bellman-Ford and the Ford-Warsel algorithm? When do you
It's
perform
base,
Bellman?
same, sir. Both are same basically.
No. Okay. See, in the
conditions are same for both.
Okay. Any difference between these two algorithms?
I'm not
Except the
sure.
method that we are. So from if you are using Bellman-Ford from the fixed source, you can calculate the shortest path to each every like the other vertices, right? But from the fluid Warsel algorithm, you can basically calculate the shortest path from any of the vertices to any of the like the other vertices.
Yes.
Okay.
Got it.
Ford, you can't use it like negative cycle. It will not work for Bellman-Ford also and for the Warsel also. Okay. And one more thing, how many times do you iterate the Bellman-Ford?
Well, number of vertices.
Number of vertices plus 1.
No. What do you do generally? Okay, what do you do generally in the iteration? You relax something, right?
Till we get constant value.
What?
Till we get a constant value.
Till we get a constant value, then though it will work for negative cycle also. Like you'll keep on doing and doing, like it will go till infinity, right? It's not like that.
I think till n-1.
Yeah, correct. So you'll have to do n-1 times iteration, right? And you are doing that iteration on what? On the edges or on vertices? vertices or edges?
Vertices.
Vertices.
Yeah, n minus 1 vertices.
Vertices.
No, in the Bellman-Ford, we generally do the iteration on the edges. Okay. So do you want me to give you an example for the Bellman-Ford? Or do you know how does it work?
Can you just explain the different
Okay,
like
I'll just
how
give
is
you one idea.
Bellman-Ford and Floyd-Warshall different?
Okay, I'll just give you an idea.
I think, sir, in some of the class also there was a discussion whether this Bellman-Ford we considered edges or this vertex. There was like it was not a clarification was not given on.
So there can be 2-3 different methods to perform this. Okay, Bellman-Ford. Okay, but the final answer that you'll be getting will be same. Either you approach it from whatever I will say or whatever you know. The answer should be same. Okay. So I have some example. Okay, I'll just show my screen once, and then you can solve this problem. So this is for the Dijkstra. Okay. So Dijkstra, you're clear, right? You can be given any source, and then you can be asked to calculate the shortest distance from this one to any of the other vertices. Okay, and you'll be able to calculate it, right?
Yes, sir.
Okay. So how does it work? So I'll just briefly give you an idea about the Dijkstra also, and then the Bellman-Ford. So let's, for example, this was our question, and then you have been asked to calculate from one. You have to calculate the shortest path to each of the other destination, any of the destination 1, 2, 3, all the other one. So you can just start with your source, and then this is your destination. Okay, the source is what I have taken 1. Okay, and then okay, I'll just put it like that. This is source, and this is the destination. The destination is 2, 3, 4, and what else? 5, 6. These are all the destination. So in the starting, the first iteration, this is the Dijkstra algorithm I'm performing, and in the starting, you can just think of that all the destination are at infinite distance. The second iteration, you can just think of that. What is the next part can be? This is the first. So from the first, you are calculating the shortest path to each of the other vertices. Okay. The second thing what you can think of from one, you can just think of which is the which of the edges is having the least weight. You can 1 to 2, right? 1 to 2 is having the least.
1 to 2, yes, sir.
1 to 2 is having the least one. So you can just write it as 7. And can you go from 1 to 9? Okay, 1 to 9 also you can go with the 9 weight. 1 to 4 you can't go. Yeah, 1 to 5 can you go? No, you can't go. So here also infinite. Because you can't go, that's why it's an infinite distance. As of now, in the first iteration. Okay, if the first iteration is this infinite, then you can just think of as the second iteration. Because we don't have limit on this. So second 7, 9, infinite. 1 to 6, can you go? No, you can't go. 1 to 6 can you go?
14.
You can go 14.
Yeah, 1 to 6 you can go. Correct. You can go 14. I guess here it is. Yeah. Okay. So in the second iteration, what can you write? Like the minimum distance is what? The minimum weight is what? 7, right? So now you have got an idea that from 1 to 2, you just have only this. Like the minimum weight can be 7, right? And that can be the shortest path directly from 1 to 2. Okay. In the next iteration, what you can think of? You can just write 1 to 2. 1 to 2. Now you have. Now in the next iteration, if you have to go anywhere else, you can use 2 also. Okay, if you are going from 1, because your source was 1, so you can use 2 now also. Okay, now you can use 2 also along with 1, and now you can go from using 1, 2 to 3, 4, 5, 6. And now can you tell me the minimum weight that you will be using if you are using 1, 2 and you have to reach out to 3? What can be the minimum weight?
9.
9 only, and that is the direct, correct? Because if you're using 1 to 3, that will be 17. But the 9 is better, right? You already know the Dijkstra algorithm ka pseudocode, right? What is that pseudocode? Somebody tell me. Du of plus if the cost of the edge UV is less than the DV, you directly replace that value. Correct? This is what the pseudocode is for the Dijkstra algorithm. This is clear to everyone, right? So if you are starting from anywhere, any of the sources, you start and then you just check the cost of going there. Okay, if that is less than whatever is earlier, whatever the weight was there earlier, if that is less, then you will not be doing anything. If that is more, then you will be replacing the value. Correct? See what happens. I'll just give you one example again. So from 1 to 3, it was fine. From 1 to 3, even though if you are using 2, it will be what? 7 and 10. That is 17. But you are already having 9 as a weight, right? As it is 17, that is what? Greater than 9. So you can't do anything. If it was less, then you would have replaced that value with 9. Correct? Is it clear or not? Clear? Okay. So 1, 2, 3. Now you can move. You already know that 9 is the only one because now using 1, 2, you will be having 17, but 17 is more. So 9 only will be peaking. Can you go to 4 by using 1, 2?
Yeah, it's 20.
What can be the weight? What will be the weight? 1, 2. If you are going from 1, 2, and you have to go 4, so that will be what? 22. Correct? Is there any other way? No. So 22 is the. So from infinite, because 22 is less, so that's why we have replaced infinite with 22. Are you getting the pseudocode of Dijkstra algorithm?
Yes, sir.
Correct? Yeah. So now
1 to 4 by 1 to 3 and 3 to 4.
No, 3 you can't use. Till now you can just use 1, 2 as of now in this iteration. Okay.
Okay, sir.
As we will be getting, so in the next step, in the next iteration, we'll be picking out one of the edges again, one of the vertices again, and that you can use it in the next iteration. Okay, till now we have just got from 1 to 2 the minimum spanning, like not minimum spanning, like the minimum shortest path from 1 to 2 with the weight 7. Okay, that's why we can use 1, 2 now. Till now, if we'll be getting the next one with the minimum shortest weight, then we can use that also. So in the third iteration, you can see that from using 1, 2, you can reach out to 4 with the 22 as a weight. Okay. Can we reach out to 5? No, I guess no. 1, 5 you can't reach. So this is infinite itself. Can you reach out to 6? Can you reach out to 6 using 1, 2?
Using 3, we can reach.
Yes, sir. It has to be infinity, sir.
No, 14 is
No,
already
it's like 14.
You directly reach to 14, no, sir.
14 is less than infinity.
Yeah, correct. So 14 is fine because you can't use 2 here. So now you can see that in the third iteration, now you can see 7 is already been included, right? 7 was for the 1, 2. Now you will choose out 9. Okay, correct. So you can reach out to from 1 to 3 with the weight of 9. Right now you can use 1, 2, 3. Okay, in the next iteration you'll be using 1, 2, 3.
Iteration, right?
What?
This will be third iteration. This will be the third iteration.
Yeah, this will be the third iteration.
Okay.
And this we are talking about the Dijkstra. Okay, so Dijkstra, if you are doing repeating also, the if once the value has been fixed, it will not be changing because you don't have any negative cycle here. Even negative age also is not there. So the values, the weight will not change. Are you getting me? If you have the negative weight, like in the Bellman-Ford, you have negative weights, correct? So that's why you have to do a fixed number of iteration. Here, you don't have any that criteria because you don't have any negative weights here. You just have positive weights every time, correct?
Yeah.
Okay. So now in the next step, what will you do? 1, 2, 3, you can use it. Now you got it from source. 1 to 2, you have got it. 1 to 3, you have got it, correct? Now, can you reach out to 4 using 1, 2, 3? Any other way better than 22?
Yes, sir.
Okay, which one?
Yeah,
1, 2, 3 to 4.
4.
It will be 20.
Okay, let's for example, it is 20, right? So now I told you that the pseudocode is itself, like if you are getting a better weight, you'll just replace it. If you're not getting, you'll not be replacing. Okay, so you have got better weight. 20 better than 22. Okay, so you have replaced that value. Now can you reach out to 5 using 1, 2, 3? I guess, yeah. Now you can reach out to 5 also. Mm,
No, how will
No,
we,
sir.
how will we reach
No,
out?
sir. No, you can't reach out. Okay. 6, can you reach? 6,
Yeah,
so
with new
better than
shortest path 1 to 3
better than
and
earlier.
3 to
No,
4.
better than, okay, we can reach it now in 9 and 2, right? So this is
Yeah, with
11.
11.
So 7 was done, 9 was done. Now which one is the better? Like the 11 one. The list one is what? 11. So now you have the minimum weight from 1 to 6 also. That is 11, correct? So now you can use 1, 2, 3, 6 to reach out to 4 and 5. I guess the 20 is the minimum for this case. Even though you are using 1, 2, 3, 6 also, the 20 will be the minimum. Correct? And whatever the 5, can you reach out to 5? Now you can reach out. You can use this 14, 9, that will be
Yeah.
21. I guess you can reach out to 5 in a better way. Can you reach out to 5 in a better way than 21? You can use 9.
Yeah, 1, 2, 3,
1, 2, 3 to
and
4
3
to
to
5.
6.
Correct. No, this way you can use it. See, this way you can use it. This one, like this. That will be 9 plus 2 is 11 plus 9 is 20, right? So you'll be
Yeah.
having 9, 20. Okay. Now you already have, both are minimum. So you just take out one and the other one. So now you have already everything, 3, 6 and 5 also, correct? So you have got all the distances, the minimum distance that you can choose out. From 1 to 2, you have 7, from 1 to 3 also 9. So all the other thing you have from source to destination, you have calculated, correct? So this is how this works. Maximum, if they can ask, this is what they can ask in the paper also. From any source to destination, the minimum weight. Yeah. Okay. The last question that you have solved, you can use the Dijkstra algorithm there also. C0 to C3, whatever the question was, you can use it there
Sir,
also. Yeah.
sir, five will come or 4 will come?
What?
1, 2, 3, 6,
Anything
4.
you can, either 4, 5 or 5, 4. Anything is fine.
Okay.
So this is the last step. Like this, there is no fixed route. It's just that 1 to 2, what is the minimum weight? 1 to 3, 1 to 4, because this is the shortest path from one source to destination, right? So this is what this is how you generally calculate for if you have to calculate the minimum weight from any source to any destination. Okay.
Okay.
Yeah. Let's, for example, for a Bellman-Ford. So for the Bellman-Ford, what happens? Yeah. So one problem we have. You can see that this is a directed graph, and here you have to use a Bellman-Ford, and your source can be this. So this is your source, and then you have to calculate the from source to all the other destination. You have to calculate the minimum weight or the shortest path that you got. Okay, from one fixed point, because this is a Bellman-Ford that you are using, and then it will work for negative weights. This will not work for negative cycle. And Abhishek was talking about the negative cycle, that any cycle that if your overall the weight is negative, that you call it as a negative cycle. Okay, that means like you can just interpret this as a, if somebody is going from one place to other place, like auto driver is using in the night, he's going from one place to other. Okay, and he's thinking that if he'll go from A city to B city, he'll not be getting any other the passenger from B to A again, so he'll be losing some money. Okay, so this is how you can think of that. After going from A to B, he's losing something that can be think of as a negative weight.
3 to weight is not given. 3 to 5 weight also.
Where 3 to? Okay, 3 to 5.
3
Sorry.
to 2.
3 to 2 also.
3 to 5 is 1, right? 3 to 5 is 1. This 1 is weight. Okay, what is?
3 to 2.
3 to 2.
3 to 2.
3 to 2.
Okay, 3 to 2 is minus 2. Everything else is given? Yeah. Now you have to perform the Bellman-Ford. Okay, I told you. So how many vertices are there?
7.
Vertices are there, right?
Yes, sir.
So you can just list out all the edges. Okay, I'll tell you my method how to, and in the end you'll be getting the same. I guess if you're using the other method also, you'll be getting the same stuff. After 2-3 iteration, I guess after 3 iteration, everything will get settled. Okay, so you'll be getting the weight or the minimum, what do you call the minimum weight from any places to other places will be fixed out after 3rd or 4th iteration. Here also the relaxation thing is same. If you are getting something du plus c times cv ub less than dv, will be replacing dv with du plus c times b. If you are getting less, if you are not getting that, the earlier one is better. You will not be replacing with anything else. So you can just list out all the edges. I'll just copy this. If it has been, yeah, it has been copied here. I'll just start this. So what are the edges? Can you tell me all the edges here? You have to relax all the edges how many times? If you have n vertices, n minus 1 times you have to iterate it. Okay. So 6 times. For this question, if you have 7 vertices, you have to iterate it 6 times. Okay. What are all the edges that are available here? Can you tell me all the edges? So one is 1, 2, 1, 3, 1, 4. 1, 4 is there. Yeah, 1, 4 is also there. So this you can just think of as a source. What else? 1, 2, 1, 3, 1, 4.
2, 5.
3, 2.
4, 6.
4, 6.
3, 5.
4,
6,
3.
7. 5, 7.
5, 7. 6, 7. Correct? So all these edges you have to iterate how many times? 6 times. So this is a bulky, but after 2, 3 iteration, everything will get settled. We can just start with the first one, 1, 2. Okay, what is the weight of 1, 2?
6.
What?
6. The weight of 1, 2 is 6.
Yeah, so the weight of 1, 2 is what? So I'll just write it in the red one. 6. So in the starting, I can just start with infinite. Everything is infinite from 1. Okay. Okay, let's start with the first iteration now. So 1 to 6. 6 is less than infinite. So I'll replace this infinite with 6. Are you able to understand this? This is fine. Are you getting me or not?
Yeah.
Okay. Now the next is, so 1, 2 is done. 1, 3. 1, 3. Where is this 1, 3? Okay. So again, infinite. So I'll cut it 5. Fine. 1, 4. Where is 1, 4? Again, infinite. It will be 5. Because this is better. 5 is better than infinite. So that will be, so we'll change it infinite to 5. Again, 2, 5. Where is 2, 5? Yeah, 2, 5. So now 6 minus 1. So infinite, I'll cut it out. 5. 6 minus 1 is what? 5. So 5 is better than infinite. So I'll replace this infinite to 5. Correct? The next word is 3, 2. What is the 3, 2? 3, 2 is minus 2. Yeah. What?
4, sir.
I'm not getting. What did you say?
No, he's saying 4.
Where?
Carry on.
Okay. Okay, so where the 2, 5 is done? Yeah, 3, 2. So 3, 2 is what? 5 minus 2 is what? 3. Better than 6, so we'll cut it. 3 will be the next value. 3, 5. Where is that 3, 5? 3, 5. So we are 5 plus 1 is 6. So 5 is better, so we'll not be replacing anything. Correct? The next one is 4, 6. Where is that 4, 6 or 4, 5? Next one is 4, 3. Where is this 4, 3? Yeah, 4, 3. So I have weight 5 minus 2. So whether I'll be replacing or not, can somebody tell me? I should be replacing the value or not?
Yeah, you should.
Sir.
Yeah, I'll be replacing with what? 3, correct?
3. Yes, sir.
Yeah. So the next one is 4, 6. Where is the weight for age 4, 6 here? Right? So 5 minus
Sir,
what?
sorry, you can't change this 2 to 5.
Why can't I change?
No, why can't you change? I'm asking. 3
Where?
minus 1, 5.
Okay,
2
so
to
I have
5.
changed it, right? I have changed 5 minus 2 is 3, right? 4 to 3 you are asking, or which one?
No, 2 to 5.
Okay, 2 to 5 is 3 minus 1 is 2, right? That is, okay, no, I guess.
Yeah, you did
There
not
was
change
6
it.
minus 1. It was 5.
No, it was 6 minus 1. Then it got changed. So 2, 5. Then we have changed it from 3 to. So after 2, 5, we came to 3, 2, right?
Acha, okay.
So the steps are what? So you have to just write all the edges first. Okay. And then you should be there in your mind that I have to iterate it 6 times. Like if the weight, like the vertices are 7, I have to iterate all the edges, relax all the edges. How many times? 6 times. Okay. I have started. This is the first iteration itself. You'll see that after second or third iteration, all the weights will get settled.
Yeah.
Sir,
Yeah,
sorry
sir.
for inconvenience. So can
Yeah.
you please like go through again, sir? Like I didn't. This is where you
Please,
were
one
going
more.
after.
Okay.
After
Okay.
which vertex
Just,
you started with? I got this.
okay. I'll just repeat it again. Yeah. I'll just
Yes, sir.
repeat it. Okay. So what I was saying is in the Bellman-Ford, first the weight should be like whatever the number of weights are there, it should be there in your mind that you have to iterate it n minus 1 times. If the weight, like the vertices are n, you just have to write all the edges, because all the edges you have to relax it n minus 1 times. Okay. Okay. And after relaxing that many times, your weight, whatever you are getting, that will get stabilized. Like after 2, 3 iteration itself, the weight will get stabilized. Okay. So the first iteration you can just start with. So I've just written all the edges that are available in this this graph. Okay.
Okay.
So and then I've started as my source is 1, right? So I have to start from 1 to all the values, all the other vertices. Correct. So the edges are 1, 2, 1, 3, 1, 4, 2, 5, all the others. So from one, I've just in the first iteration or in the 0th iteration, we can just think of all the values at infinite distance. Okay.
Okay, sir.
Okay. Now you have to start the first iteration. Okay. And you already know how does that Bellman? So it's same as the Dijkstra. Whenever you are getting, if you already know du plus, if the cost of going from u to v, whatever the cost it is, if it is less than dv, then you replace the value. Okay. Otherwise you should not doing anything. Okay.
Okay.
Yeah. So 1 to 2, you can just see that the weight was 0 in the starting. For 0 to 0 is 0, right? Correct.
Yes.
Yeah. So 0 plus 6 is what? 6. 6 is less than infinite. If you are getting something less than the weight of the 2, then you will replace. So you have to cut it, replace it with 6. Okay. 1 to 3 now. So 1 to 3. 1 to 3, you can just think of 0 plus 5. 5 is better than infinite, right? You have to choose out the minimum value, right? So you'll cut it. 5 is the limit. 1 to 4 now. So where is 1? Here. 1 to 4. 0 plus 5. It is better. So you'll cut it. 2 to 5. Again, where is 2? 2 to 5. So 2 to 5. 6 minus 1 is what? 5. So 5 is better. So I'll replace with 5. Correct? So this is 2 to 5 is done. 3 to 2 now. 3 to 2. My 5 is the weight. Minus 2 is what? 5 minus 2 is what? 3. And 3 is better than 6, right? So we'll cut it.
Yeah.
I'll put it 3. Now 3 to 5. 3 to 5 is what? 1. So 5 plus 1 is 6. So should I replace or not?
No, sir.
No, we don't have to replace because 6 is greater than 5. Whenever you are getting less, then only you will be replacing. Otherwise, you will not. 4 to 6 now. Or 4 to 3 for the next one. 4 to 5 minus 1 is what? 4. This is better. 4. 4 to 6. Where is 4 to 6? 4 to 6 is done. 4 to 3. Yeah. 5 minus 2 is what? 3.
3.
So 3. Correct? Now 5 to 7. Where is 5 to 7? 5. And then 5 plus 3 is 8. This is better. So I'll replace 6 to 7. 6 to 7. 4 plus 3 is what? 7. Again, I'll replace 7. Got it? This the first iteration done. This we have to reiterate how many times? 6 times. If the vertex is 7. Now the next iteration. Again from 1 to 2. 1 to 2, do I have to do anything? 0 to 6. Do I have to do anything? Do I have to replace anything?
No.
No, sir.
No. 1, 2, 3. Do I have to do anything? 1,
No,
2. Nothing. 1 to 4.
No, sir.
See, in the second iteration itself, you can see that many of the values are got like
Less
stabilized,
than.
right? 1 to 4, if you see, this is done. 2 to 5, do I have to do anything? 2 to 5, yeah, 2 to 5 we have to, because 3 minus 1 is what? 2. So we'll replace it with 2, correct? 3 to 2. 3 minus 2 is what? 1. So I'll replace with 1, correct? 3 to 5. 3 to 5 is done. 3 plus 1. This is better. 4 to 6. This is done already. Do not no need to change. 4 to 3. Where is this 4 to 3?
Sir, how did that 2 become 1?
Where?
That 2, vertex 2.
Vertex 2. Yes.
Yeah. How did that become 1?
Okay, this one. You're talking about this value.
Yeah.
Okay, so yeah. So 3 to 2 was there, right? 3 to 2. If you're going from 3, the weight of 3 is what? 3, and 3 to 2 is minus 2. Okay,
Yeah.
if somebody is moving from 3 to 2, he's losing something, right? So 3 to 2, 3 to minus 2. So you're left with 1 and you'll replace it. Correct? So got it, right? Where were we now? Okay, so I guess
4 to 6. 4 to 6.
okay, 4 to 6. 4 to 6, because if we'll, yeah, 4 to 6. 4 to 6 we are done. 4 to
No
3 we are
change.
done. I guess 4 to 3, no changes. 5 to 7, is there any change? 5 to 7, yeah, 5 to 7 we have to change it, correct? On 6 to 7, do we have to change it? No, we don't have to change. 6 to 7, 4 plus 3, 5 is better, correct? Now the next iteration, 1 to 2, no change, right? 1 to 3, no change. 1 to 4, is there any change? 1 to 4, no. 2 to 5,
No,
is
sir.
there any change? 2 to 5 we have to change. 1 minus 1, it will be 0, correct?
0.
Yeah. 3 to 2, 3 to 2, any changes? 3 to 2, no changes, right? 3
No
minus 2, no change. 3 to 5, 3 to 5, 3 to 5, no change. 4 to 3, no change. Yeah, 4 to 6, no change. Yeah, 5 to 7, 0, 3. Yeah, 3 is better. 6 to 7, no change. I guess now we are coming in third or fourth iteration. I guess third iteration. 1 to 2,
Third
no
iteration.
change. 1, 3, no change. 1, 4, no change. 2, 5, 2, 5, 2, 5, no change. Now there is no change. 3, 2, no change. Okay. 3, 5, is there any change? 3, 5, no. No. The 1, 0 is better. 4, 3, no change, I guess. 4, 6, no change. 5, 7, no change.
Yes.
6, 7, no
Sir.
change. Yeah. So now we
5
are
to 7.
done.
Sir, 5 to 7.
5 to 7.
0.
0 plus 3. 3 only. 3
We
was
already
already there.
updated that.
I
3
did.
was already there. 3 was already there. So no change. 0 plus
Okay.
3, 3 only. So there is no change. Now we have done, right? After third iteration itself, we are seeing that there is no change. So fourth also, in the fourth iteration also, there won't be any changes. Now you can see that the values that you have got is the minimum. Okay? Got the idea about the Bellman-Ford?
Yes, sir.
Yeah.
Yes.
Yes, sir.
See, this is like very, like, this will not be asked in your paper. Like, mostly it will not. Basic idea will be asked. All iteration, number of iteration, where do we use it? All those stuffs will be asked. But the algo will not be asked in the exam. Okay, Dijkstra can be asked, but the Bellman-Ford and the Warsaw mostly will not be asked. Okay, so you should be knowing the basic idea where you can use it, all those stuff. But the important portions are Dijkstra and then the Krustal and the Prism. Okay, all those things you should be knowing. Okay, I guess this is clear, and then you can solve. So whatever the Abhishek was giving you the problem, you can solve that problem. Okay, I'll just give you an idea about the minimum cost spanning tree also. The two, are you aware of those two algo or not?
Sir, can you
Crystal,
please
I am
tell the
aware.
difference
I know.
between
What?
Floyd Warshall and this
Yeah, so there is
Bellman-Ford?
one difference. Yeah, only one difference is, see, here you just have to start from one. So source to destination, your source is fixed, and then you have to go to, so from here we have started from one, right? And then you have to find the shortest path from one to all the other vertices. In the Floyd Warshall method, what you can
We can choose
start
any
like,
of the edges.
yeah, you can get it from any I to J, right? So there is
Any
no
minimum
fixed source.
edge. Yeah. Okay.
Yeah.
So
Okay.
basically we will take in consideration all the same numbered edges at once, right?
I didn't get that. What does that mean?
Like there like
See,
two.
in that method, what do you do? Basically, you starts with something. Say, so in the you already, if you have a 4 vertices, you start with first in the first iteration, you just write the adjacency matrix. Is there any direct connection or not? Right. In the second iteration, what do? You just take the help of one vertices, right? The 0th one. And the second iteration, you take the help of the 2 vertices. In the third iteration, you take the help of the 3 vertices, and then check out what are the minimum, like the minimum weight you can reach out from I to j. This is what you do in the Watson, correct?
Yeah. Yes.
Yeah.
Yes.
Yeah. So in the first iteration, you just write the adjacency matrix. Is there a direct connection or not from each I to j? And if there is any direct connection, what is the minimum value? And if that is minimum, then you write it. If there is nothing, then you write it infinite. Correct? And then the second iteration, SP is that you called 1. SP1, you just take of help of one vertices. Extra one, like extra with what? Like you take help of 1 vertices. In SP2, you take help of 0th and the first vertices. Correct? And then you reach out to the I to j, any I to j. Correct? That is what you do in the that fluid Watson algorithm.
Understood.
Yeah. Everyone got the idea, right?
Yes, sir.
Sir, sir,
Yeah.
is there any short trick like this Bellman-Ford one in for this word Watson?
No, like so that itself is easy one, right? Like that takes a lot of time. That is what I'm trying to say. That takes a lot
Yes,
of
sir.
time. You have to, you can do some error also. Like adjacency, you'll not be doing, but from next time, like SP1 to that is fine.
Yeah,
But
it is
SP3
boring
and 4,
also.
you'll have to use your mind
And
and
very
then
time consuming also, I think.
yeah. But most probably will not be. As you should be knowing the basic concept about that Watson, okay, fluid Watson algorithm where you are using and all those stuffs, okay, not more than that. Okay, let's move to the next part. I'm just giving you one graph, and then you have to tell me the minimum cost spanning tree. You can use any of the algo. I'll give you the answer with both the algo will be solving the one question. Okay. So this question is important, and you should be knowing. And this is simple also. This minimum cost spanning tree. Okay. You already know that how to, like, this spanning tree. We are just, any graph can be given to you, and then you have to find a spanning tree. You have to take out one spanning tree from that graph that is of the minimum cost, right? This is what you do in the minimum cost spanning tree, right? What do you mean by a tree?
Yes.
What do you mean by a tree? Can somebody define me a tree? Like, what do you mean by a tree?
Covering all the
graph.
covering all the vertices with minimum edges using minimum
Correct.
edges.
Correct. And there should not be any cycle, right? That if
Yes, sir.
vertices should be connected, there should not be any cycle, and the minimum vertices you will be using, minimum edges you will be using. Correct. If you are even one extra edges, you will be forming one cycle. Correct. This is what the tree
Yes.
means. Even though if you are
Yes.
using one extra edges, you'll be ending up getting a cycle. Let's solve one problem. I guess the definition is clear to everyone.
Yes, sir.
Yes, sir.
So let's start with one example. I'm just giving you one example. This is A. A, B, C, D. Okay, all the weights are there. Everything is there, right?
Yes, sir.
Yes.
Yes, sir.
Okay. Just tell me, if you are creating the spanning tree, minimum cost spanning tree, what will be the weight? You draw it and then tell me. Any method you can use, Kruskal and or Prism, anything. Kruskal you already know, right? Kruskal, how do you perform Kruskal algorithm? You just arrange all the weights in some ascending order, right? and then you start with
Yes, sir.
the minimum one.
Minimum
correct?
weight. Yes.
Yeah, you can start from, and while making connecting, you don't there should not be any graph, like the cycle you should not be making. That's very simple. You start with any, I guess 3 is the minimum. Yeah, you can start from AC or maybe EF, anything. But the minimum weight, just take your time, 2 minutes. It should not be more than 2 minutes. Yeah, and this type of problem you'll be getting in the exam. I'm just telling you. So practice this crystal and prism.
Sir, I mean, we can master one and we will get the same answer.
Both are simple. So see, there can be some basic questions like in the Kruskal algorithm. Whenever you draw use the Kruskal algorithm, every time there should not be like in the end you're generally connecting the tree, right? In the prism, from the starting all the tree that you are making from the starting is connected, right? So this small things can be asked. You should be knowing but whenever you'll be asked to calculate this the weight, minimum weight, then you can use any of the method. Both the methods are simple, right? What is the weight? Has anybody calculated?
I'm getting 16.
16. Okay. 16, how do you get I get 16
21.
Yeah, I guess 21 is correct, I guess. Yeah.
Yes, sir.
But okay, let me check how 16 you are getting. Maybe 16 can be the answer, I guess. But I don't think so.
I think she missed D.
Can you start solving this? Okay, let's make it small. Let's use this crystal only. So you have to tell me how will I solve this. Okay. Okay, so which one is the smallest? From where? Okay, I should start with A. Okay, tell me from where should I start? AC?
B.
AC, yeah.
So B is the smallest.
Yeah, B is the smallest, right?
Yes.
Yeah.
This is D. Okay, my pencil is not working, so I'll just be. I can't write it now. Okay. Give me 2 minutes. I'll just charge it. Okay, till that time, take some 2 minutes to charge. So till the time, just let me know. So B, E, you will start with, right? Just okay. So from there you will get 2. The next one is AC or EF, anything you can take, correct? So 3 to 5. Are you able to hear me or not?
Yes.
Sir.
Yes,
Okay.
sir.
So 3 and 2, 5. AC, and next part, what will you take? Okay, after that you will take EF, right? So 3, 3 and 2. So 3 to 5 and then 8. The next one, 4 you can take, EG you can take, right? Because
edges so that we know that it doesn't form a loop.
yeah. It should not be forming a loop. Yeah. So that's why we are taking 2 and then this AC3, then EF3 and then EG3. We are not taking GF because that will form a loop. So 4 plus 3 is 7 plus 2 is 9 plus 3 is 4, 7. 4, 3, 7, 2, 9 and 3, 12. After that you can take BC is 4. So 12 plus 4 is 16. and I should be including D because D is left. So to include D, we have 5 here. So I guess 16 plus 5, 21. 21 should be the answer. Because I guess we were getting 16 because we were not including D. All the vertices should be covered, right? That's the minimum, like the mid tree. You only told the definition of
I
the tree,
forgot
right?
that D.
Yeah.
21 is the correct answer.
Yeah. So from 16, I guess this BE, and then you have to take AC, DC, EF, EG, okay, and then one more was DC, I guess. Yeah, that's the correct answer. If you're using the Kruskal. Is it fine to everyone? Understood?
Yes,
I'll
sir.
just try to write it, whatever it has been charged. So AC, okay. Okay, this is not charged. AC, and then this is 3. Then this you will start with B because you have to arrange it in a ascending order if you are using Kruskal. 2, then 3, and then one more 3 was there, this one 3. And after that, what you can use is after 3 we have 4, right? So this 4 you can use it. You can't use the next 4, this one, because it will form a cycle that you can't use. So you'll have to use this 4, right? So after 4 you have 5. 5 is here. You can't use it because it will make a cycle. So the next one you can use it, this 5, right? So this is your tree and this is your minimum cost time tree. So 5, this is what? 7, 2, 9, 3, 12, plus 4, 16, and 5, 21. Okay, so 21 is the correct answer. Anyone is having any confusion in this?
No,
sir.
No. So this type of problem will be asked in the exam.
Sir, what about 6, sir? We have not included 6.
No, you will not be taking. Yeah, you will not be using 6. Why will you use 6? So this is the like, see, the definition you have already, spanning tree, the definition you already know, right? All the vertices you have covered, correct? And all the are connected. There is no cycle in this. So why will you use 6? Will not be using 6. If you will use any of the 6, will end up forming a cycle. See, let's for example, this 6 you are using, it will be a cycle. If you are using this 6, cycle. Again, anything you'll use, it will be a cycle. So you can't make a cycle. Okay?
Yes, sir.
Sir, instead of using EG, can we use FG?
Easy. Yeah, you can use where easy. Okay. You're telling me to use FG. Where is that FG? FG.
You can use.
Yes, sir.
Yeah, you can use anything. Yeah, do not use this. You can use anything. Yeah, correct. You can use it.
Okay, sir. Thank you.
Yeah. So I guess this is clear. I guess. Any other doubt that you have?
No, sir.
Yeah, Abhishek, you can just solve the end problem, the minimum cost spanning tree problem. Are you there?
Yes, sir.
Yeah, you can just solve some problem that is there in the end, and then we'll just end the session. Okay. I guess, is there any confusion, any doubt in any of the algo? Anyone?
No, sir.
No, right? Okay, then you can just solve the last 2 problems that is there, and then we can just.
Sir, one doubt.
Yeah,
What is the difference between Crucial's algorithm and Prime's algorithm? Once you tell.
So there is, see, the final answer will be getting the same. Only the approach that you solve is the difference. The Kruskal, you just, all the weights you just take out. So whatever the age is there, all the ages will be having some weights, right? You just put it in the ascending order, and then you start with the minimum weight, okay? And you connect it. So the way we have done it here. So from the starting, we were just taking out the minimum weights only, the age with minimum weight. So in between, the tree was not connected, right? Have you seen, like, you have seen that, right? So in the end, it got connected. But in the prism, from the starting, the tree that you are making, that will be connected itself. So from that Prim's algorithm, what we do is, we start with the minimum weight edge, okay? And then let's, for example, we are starting with B. Okay, if we are starting with B, we'll just take out the connection of B and E. Okay, what's the minimum in that? Like, we'll be choosing out to B out of BA, BC, BD, like out of that. Okay, but here in the Kruskal, you just follow like the minimum. You start with the minimum weight. Okay, and you go till end. but in there's just the answer, final answer should be same. The will be always same. Only the approach is different in both the cases. Okay.
Okay, sir.
Yeah.
Prime's algorithm, from where we have to start?
There also you just start with wherever the minimum weight you are getting. Like you'll start with B. There also.
Okay.
Okay, but so you'll be, but there what will you do? You'll not be jumping directly to AC in that case.
Okay.
Okay, you'll be just taking out of this 5, 4, 6 or whatever is there in the VE, the vertices. You'll just take out all the edges connected to those vertices. Whichever is the minimum, you'll just start with there.
Okay, sir. Okay.
Yeah.
Okay,
Yeah.
sir. Thank you.
Okay. So I hope there is no doubt. Then I'll just yes. Okay.
Will you share this PDF?
Yeah. This PDF is already uploaded in the supplementary content. Go to the supplementary content. There will be a folder, solve with us folder. So there you can find this folder, like this file. Okay.
Okay, sir.
Yeah. Yeah. I've just stopped the sharing. You can just solve 1-2 problem and then you can just close it out. Okay.
Okay. Okay.
Okay. Thanks. Thanks.
Okay, is my screen is visible? Hello.
Yes, sir, it is visible.
Okay, solve this problem. Solve this. So consider a weighted graph G, which has 7 vertices, P, Q, R, S, T, U, V, which represents by a adjacency matrix. So this is an adjacency matrix. You have to draw the graph, and then you have to find what you have to find. Then you have to find the order, which can be added to the set if you perform. So you have to write the order of TV. So what is TV? TV is 3 vertices. Okay. So first of all, draw the graph. Try to draw the graph of the adjacency matrix. Then is the adjacency matrix is visible to you guys, or should I zoom
Yeah,
in?
visible, sir.
Visible.
Abhishek, what are we going to do?
In this problem, you have to find the tree vertices. If you remember, tree vertices is means you have to raise the minimum cost of spanning tree, the edges in the order, so that the
Okay, tree
yeah, tree vertices. So
Here 0 means no edge, right?
yeah, 0 means no edge. So there are two types of things. I will say that it is tree vertices and tree edges. If you remember, here you have to find the tree vertices. Starting with vertex R. So here the algorithm is starting with vertex R. So are you able to get the graph? If it is done, then you can put done in the chat box. Let me just Q, R, S, U, U, P, Q, S, Q. Okay, so let's write this vertices. So have you drawn the graph? Is anybody finding difficulty in drawing graph? Yes, no. Am I audible?
Yes, sir. Still solving.
Yes, sir,
Yes,
you
sir.
are audible.
Okay, are you guys are solving the question?
Yeah.
Okay, so I'm waiting for 4
Sir, U is missing.
minutes. Okay, okay. So let me start with this. So P and P, 0, right? P and Q, is there any vertex between P and Q? Yes, that is 6. So P and Q is 6. P and R, no vertex is 0. P and S, 0. P and T, yeah, there is a vertices that is
Sir,
9.
it's been asked that we have to start from R, sir.
I am just drawing graph. Then I
Okay.
will start. Okay. Okay, okay. If you said then we can start. Graph will not be affected. Okay, okay. Let me start with R.
Oh,
R,
sir, I thought you were drawing that tree. Sorry, my
I am
mistake.
just drawing the screen.
Okay,
The
sir.
graph of this. Okay. So where we are PR and PUPB is there is PB, that is 7. Similarly QP done, QQ 0. Okay. QS. QS is 8. What about Q? Nothing. For R, RU. RU is what? 1. RV is 3. And then let's move on to the S. SQ done 8. ST is 2. And we have PT is done. PT is done 9. What about TSTS is already done 2. U UR U and R 1. Okay. U and V is 5. B and oh, all are done, right? Is there any left? V already V
No, sir, done.
V and T done. V and R done 5. Sorry, 3. V and R 3 and V and U 5. Okay. Now you have to start with. Now this is our graph. Now you have to start with the vertex R. This is your source, right? So first of all, what is your TV? First initialize TV to 5. Okay. And you have to also find a TE. But I'm not in this question. There is need to find TE. I don't think so. Okay. Okay. We can get so TE. We can also initialize TE to 5. Okay. We are initialize TE, U and TV to 5. And then what will be the first step? First of all, which vertex from R you have to choose one vertex. Okay. So our source vertex is R. Then TV is become R, right? TV is become R because this is our starting point. So you have from R you have to choose one edge. Which edge you should choose? Minimum cost, right? Minimum cost spanning tree. You have to choose the edge which has minimum span. So which edge you should choose? Tell me the edge. V, right? RU. This edge is from R you can there is two choices only. You can either choose this edge and this edge. 3 and 1. 3 and 1. So you will choose 1, right? So TE will be what?
RU.
And this U is included here. And now this is the vertex we have. Now again you have to choose the minimum vertex. So tell me which is the minimum vertex then after that.
So
Again
PV
choose the
V to
again
P.
choose. Yeah, V2. This is the minimum, right? From this one V and R. V and R are minimum. So from R you will choose V and R. This V and R. So TV is equal to then R U V and TE is equal to
Sir,
RU.
shouldn't it be VP, sir? Because you have written whatever you have written will make a cycle.
No, I am choosing this one. This and this only. Not
No, it won't create a
it
cycle.
won't be now. We are
He's
just choosing the
stopping at V.
vertices. This is vertex
Yeah.
or V. So this is our another vertex. This is not creating any cycle. Okay.
Yes, sir.
And then which vertex we have to choose?
Okay. P, sir.
So from V there is only one. This one, right? VP.
VP.
So DV is equal to R U V and P. V P. So this one is also done. So we have done with this vertex, this edge, this edge, this edge, this vertex, this vertex. This vertex. Now you have to choose another one. So for this part, which vertex you will choose?
PQ.
PQ, right? Because there is two choices. In P, there is two choices. Either it will be PT that is 9, or PQ, which is 6. So you will choose the minimum one. So TV is equal to R, V, P, and Q. And T is equal to R, U, P, Q. Now, which vertex you will choose next? In Q, there are
the only vertex.
only one vertex, that is
QS.
QS. So TV is equal to R, U, P, Q, S. R, U, P, Q, and what? Q. S. And what will be the last one?
ST.
ST.
This T is remain, right? You will choose
Yeah.
ST. This is our final TV. Equal to R, U, V, P, Q, S, T. So this is the question. This is the answer. This question is asking about. So, Swan.
Sir, I have a question, sir.
Yeah.
Sir, in starting, we can write as URV, but you have written RUV. Why so?
Sorry, which one?
Sir, answer should be URV.
We are starting from R.
R, right?
Yes,
We
sir,
are
but the
starting
source
from
is
I.
R.
If you see here, the question is said that the starting vertex is R.
Oh, okay, okay. Okay, sir.
Okay.
Actually, I have not seen the.
Got it? Any doubt in this?
No, sir.
Okay.
No,
So
sir.
same
No,
graph
sir.
will be same graph will be there, and now you have to use the. So let me show you. So this is the question. Fiscal algorithm, and then you have to find. So find, now you have to find the TE, and in order which the age is at, means you have to this is already. So you have to find, we have to perform the Kruskal algorithm. What this algorithm says that increment the minimum cost spanning tree of a graph from what is E. This will be the ages sorted in ascending order by weight. Means you have to choose the age by ascending order. Previously, we have chosen the in Prim's algorithm, you have chosen the TV, the tree, by means choose the minimum weight. We have chosen the minimum weight and then appended in TV, right? We have chosen the minimum weight and appended in TV. But in this one, you have to choose the minimum weight of what? H, minimum age weight, and sort it in ascending order. So first of all, you have to find TV and then sort this TV in ascending order. So again, the same graph is there. Copy that one. Should I copy this graph? So you have to find. So yeah, find the which age is to be added. Find TE. So TE should be arranged in. We have already found TV TE. That is, what is our TE? RU. If you remember, RV and
VP.
VP.
PQ. No.
VP, PQ, QS, ST. VP, PQ, QS, and ST. So arrange this edge and tell me the weight of this edge. This one is, so the weight of this edge. Tell me the weight of this edge.
1,
First of all, 1. This one is
3,
This one is
7,
What about
6,
PQ?
8, 2.
Now arrange this weight in ascending order so that it should not how many cycles. So arrange this weight. So the first one will be what? RU. It's fine, right?
ST,
ST.
RV,
RV. And then
PQ,
this one is done. This one is done. This one is done, and then PQ. PQ.
So PQ.
Then
VP,
PP या PP. And what? Next one is QS. Right. So we have just arranged this edge in ascending order that get the percentage. So if you perform the push-pull algorithm in the order which edge is added to T is this is the order. So which we have already implemented the what prism algorithm. That's why we will get this value, right? If you have seen that we have already implemented, but in question exam, this question 2 are independent. We will ask the independent question. For the shortcut, I just implement. So this is the graph we have. We have using P, this is V, this is R, and this is Q. Actual way is to find, you have to just write all the edges in the ascending order, that is TE, all the edges randomly. First of all, you have to start here. There is no order is given, right? So you have to just write any edges, means RU, RV, UV. You have to write all the edges. VP, PT, ST, QS, and PQ. So is there any edge left? So we have to choose, we have to write the edge weight, and we have to choose the edge which has the minimum edge weight. Okay. So here, okay, I'm just removing this one because I'm just solving this question because we have just used the prism algorithm previously to solve this problem. So let me solve this. So these are the edges we have. These are the edges we have. And now what we have to do? You have to choose the minimum edge weight. So RE, minimum edge weight, that is RU. RU you will choose, fine. Okay, these two are different. And then what is the next edge weight? ST, right? Because ST has minimum weight. This one. Are you able to see? Are you guys are able to
Yeah.
get it, or it's just creating confusion?
Yeah, getting.
Look, wait, I will write the edge. It is 3, it's 5, it is 7, PT is 9, ST is 2, QS is 8, and then PQ is 6. So I have written is 1. Here ST is done. ST is 2. And what will be the next edge weight? You will choose this one, right?
RV.
RV.
Yeah, RV.
RV means you have to mark all the edges. You have to mark all this. Let me mark what edge I have chosen. So RV is done. ST is done. And we have what will be the next edge? RV is done. Okay, what will be the next choice? This one,
UV.
right? UV. But if you choose UV, it will create a cycle, right?
Yeah.
It will create a cycle. If you remember, it will create a cycle. So you can't choose UV. So you have to cross UV. Just cross this one, UV. And then what will be the next edge you should choose? PQ. So write PQ here. PQ is fine. So draw PQ. So PQ is done. What about the next edge?
VP.
VP. Which is VP. So this one is also done. And what about the next stage?
QS.
It says PQ done. QS. So if you choose QS, it will be fine. QS collected. QS. And then what will be the next stage? Already done, right?
Choose PT, yeah.
Yeah, because it will create again create a cycle. Choose PT. So this is the sequence. Yeah.
Also, sir, wanted to ask, no matter which algorithm we use, we'll always get the same answer, right?
For the minimum cost spanning tree, yes.
Yeah. Okay.
At the end, you will get the same answer. But suppose if the question asks that find the value of T in Kruskal algorithm. Kruskal algorithm, you know that Kruskal algorithm arranges the vertices in ascending order. But Prism algorithm doesn't arrange any vertices in ascending order. If you see that it doesn't arranges these vertices. So see, that is the difference. You have to know to solve this problem.
So mostly they'll mention which algorithm to use.
Yeah, it will be written. But you have to remember that what the difference between these two algorithms, right?
Yeah.
So yeah, that's all. That's the two question last time. So, do you have any doubt? It's already solved by sir.
So thank you for the session.
Thank you, sir.
Thank you, sir.
Okay, thank you.
Thank
you, sir.
For joining.
Thank you, sir.
Thank you.
Thank you, sir.
Hello, sir.
Yeah.
Can you explain one doubt?
Okay. Let's give it.
Actually, in matrices, from A square matrix, how you will find out A matrix?
From A square matrix. If
Yeah,
A square
from
matrix is given. So tell me an example. Do you have any example?
Yeah, in graded assignment, A square. Actually, suppose A is an adjacent matrix of the connected undirected graph. If A square is given some matrix, and the shortest path between the two vertices has length at most 2.
Okay, tell
Then
me the
which are,
question. Tell me. I just copy that question.
yeah, A square is equal to
No. Question number. I'm asking the
question number 3.
Week.
Yeah, graded assignment, question number 3.
Okay, the deadline has already passed?
No,
Yeah,
sir.
yeah. Today night.
No. I can't
Okay,
explain.
sir.
So yeah,
Okay.
so let me give
Actually,
you.
only one doubt that is there. How we will find from A square to A? Only that you clear if it is
So
okay.
what is A square?
Shankari, they are not going to give an answer.
Okay, sir.
I can talk to you later.
Yeah.
Okay, sir. Okay.
You can itself help each other. If you know, you can help me here. So,
Okay.
see, suppose A is an adjacency matrix conducted by A square. What is the shortest path between two matrices has more? Okay, so yeah.
Basically, in that question, sir, I'm also having problem in finding this A square, sir. I'm not
you
getting the
can
exact
toss,
value.
Yeah,
you guys can.
I no need full answer, but from A square, how you will find out A? Only that doubt I have.
Okay, I will explain what is the meaning of A square.
Yeah.
A square means
Yeah.
that shows from which vertex to which vertex you can go in 2 hops.
Yeah.
That's all it says.
These two depends hops.
2
Means
hops.
suppose if
Yes. If you got to go through one more vertex to reach that point. If
Yeah.
you
Okay.
3 to 4, you should be able to go 3 to somewhere and come to 4.
Okay.
Okay. In that,
Okay, sir.
I know this problem was not explained by the teachers or the course, but
Yeah.
if you clearly look at the problem, there is a 0, 0, 0 somewhere. That will
Okay, sir.
and then look at the graph. From that point to the other point, there should not be a 2-hop route. If it is a direct route, that doesn't matter.
Okay.
Suppose okay. Suppose
A
if
square,
there if you want to
basically
go directly,
A
if
square
there is a
always gives you the number of routes with 2 hops. A cube will give you the number of paths with 3 hops.
means suppose if you want to go to 4 and there is no direct path, so what he will do? He will go to 2 and then go to 3 and then go to 4, right? There is this way.
Yeah.
So this is your first hop.
No, Abhishek, there is a difference between A and A square. In
Yeah,
A,
yeah, that's
there will be a direct path.
yeah. If suppose we are asking that A, and
I
if
to
there is
J, if
okay,
there is
let
no,
me write the adjacency matrix of this A.
yeah,
Okay,
he is talking about.
1, 2, 3, 4.
I know this problem was a little.
It's already explained in the if you watch the lecture, it's already explained. Sir has
No, sir,
also
they have his sir has only explained the code that the from I to K and K to J.
if you
He has
if you
not explained
listen the
any
lecture.
examples, sir.
No,
Example
he
he has
has
not explained.
okay.
It's very hard to imagine, sir. In fact, I'm also having problem in this
So suppose if
matrix
I want to find
multiplication.
A, so this is A is an adjacency
Sir,
matrix.
your screen is not visible, sir.
Okay. Oh, sorry. Is it not?
What Bhaskaran sir said, I understand, but the problem is like I'm not able to relate when I'm putting all those concepts on the paper.
Now it's visible.
Yes, sir.
Yeah.
So
yes.
see here. Here we want to find the matrices. Suppose this is a graph we have, and you can see that there is no direct path between 1 and 4. So how we will get the path? Suppose okay, let me find the adjacency matrix of this graph. So from 0, this one is 0, 1 to 2, there is a path. From the path 1 to 3, there is path? No. 1 to
No,
4,
sir.
no path.
No.
From 2 to 1, there is a path. From 2 to 3, 2 to 2, 0. 2
There is
to
no
3,
path.
there is path.
Yes, one are path.
2 to 4,
0.
no path. Again for 2, 3 to 1, no path.
1.
3 to what? 3 to
2.
2, there is a path.
There is a path.
3 to 3, no path. 3 to 4, 1. What about 4? 4, 0,
0.
0, 1, 0.
0.
Okay. So this is the adjacency matrix.
Yes.
Suppose if someone asks you you have to find the value of A square. So if this is given, you can directly form by A cross A, or if you do the matrix multiplication, you can directly find A cross A. This is A square. But if the graph is only given and A is not given, so how you will find A? So you have to find. So similarly, 1, 2, 3, 4. 1, 2, 3, 4. You have to again write the adjacency matrix. A square means there is no direct path. There will be no direct path. You can, from 1 to 1, no direct path. 1 to 2, there is one path. But you can go to 3. By one hopping, you can go to 3, right? You can go
Oh,
to
yes.
3 by one hopping. So what it will be? One path. Again, you want to go to 4, but by one hopping you can't go because you have to hop
That will be 0.
2 times, right? Means you
Okay.
have to hop 2 times.
That will be in
You
A
have
cube.
to, yeah, that will be 0 here.
So
But
don't confuse them.
yeah.
Just stick to A square. Tell them where from 1 anybody can go in 2 hops.
Yeah, but here for A2 you have to go one hop. In one hop, where you can go.
Yeah.
Similarly, for 2, you can
Yes, sir.
directly go
Sir,
to 1.
From 2 you can
it's
go to
like
4. From 2 you can go to 4.
Yeah, from 2 you can go to 4. You
Yeah.
can go
Yes.
all the points except
No,
this,
except
right?
2.
Because this is
no,
directly
3 you
connected.
can't. No, 3 is not 3. There is 0
3 to
because
1 you can't go.
wait, 2 to 3 is 0 because it is direct connection. It is not a double connection.
Okay.
You got
So,
to
sir,
understand. Look, A square means double connection. It doesn't care about
Okay,
any other
sir.
connection. Okay.
So one more
Bhaskaran, sir,
doubt. If you
sir,
have written, you have written 1 to 2, you have
yeah,
written
yeah,
path is there.
1.
So it is
Like,
not double connection, no, only one connection from
I,
1 to
I,
2.
I will put it very simply. A is a direct connection. A square is
Double
2
connection.
connection.
Okay.
You got to change the train.
Mm-hmm. Okay, sir. Okay.
A
so
cube
Understood.
is 3 trains you got to go.
Mm.
Even if you can go directly, it will not come in A cube.
Mm.
That is A.
Yeah.
A is simply direct train. A square is 2 trains. A cube is 3 train. A4 is 4 train. That is how it goes.
Understood, sir.
Abhishek, sir, so this 1 and 2 also, it will be 0 only then.
Okay, let me
Zero.
check. Let's
In that
find
A
the
square matrix you have written 1 to 2, 1 you have written. Actually, that is 0, no?
That's I'm
Record.
checking. Just
I'm
wait.
not sure. Are you familiar with matrix multiplication?
Yes, sir.
You can do that whenever I mean, all you got to do is after multiplication, you got to exceed. If it is more than more
It
than
should be
1,
0.
more than 0, make it just 1.
Mm-hmm.
If you allow that number to be multiplied and then added up, then there is another interpretation for that. In A square, if you find 2, there are 2 roots.
Okay.
You understand? There
Understood.
are 2 roots. But right now we are not talking about the number of roots. We just want to know whether there is a connection after 2 hops to reach the station. So, I mean, there are different levels of our own understanding. So, just limit it to 0 and 1, then it will be easier.
Okay, sir.
This is the problem I faced in one of the TA class. The teacher simply told that multiply A into A using the concept of Boolean algebra. They did not mention
Yeah,
about this
the
2 hop
reason of,
multiplication.
look, I mean, the purpose is not to get complicated, no? Look, there are
Yes,
so many
yes.
things we can do. If we tell everything, then the people, I mean, we are slowly starting. We are talking about 15, 16 years here. You know?
Yes, sir.
Yes,
It's
yes, sir.
okay.
Yes, sir.
Slowly. All I would suggest the student should understand what is the meaning of a loop. What is the meaning of the weightage?
Yes, sir.
I heard lot of discussions about a negative loop. What does it mean?
Negative loop or cycle.
Yeah. If we need to understand things because these are the technologies and techniques and the mathematics tools. What are they there for? They are there to help us to understand the world. Not just formula, somebody comes and then Bellman comes with the algorithm. That's okay. They got to help us to solve a problem in life. I would suggest every one of us start thinking like this. What does it mean? What do you mean? What do you mean by a negative loop? Does it exist? In which situation?
So this is your A square. If you multiply this matrix, this is your A square, and you can relate with this.
Yeah, I understand that. I know. I'm just because I've been watching, I've been involved into this to see how my future generation is going to come up. That's why I'm talking.
So yeah, if the alt route is clear, so then we can close the session because it's
Thank you.
10:30.
Thank you. Thank you.
Okay, thank you, Bhaskar.
Thank you, sir.
Thank you, Vasan. Thank you, Abhishek.
Thank you, sir.
This is the same problem, sir. This A square problem, sir, over here in the graded assignment also, week 11, question number 3, sir. The graph that is given to us, even for that, even we are calculating A square. The A square we are getting is not matching the A square that is given in the question.
They haven't taught you the matrix multiplication. It's already been taught you. In the TA session, we have already taught the matrix multiplication.
I don't know, sir, maybe not able to understand it. Okay,
So
sir.
yeah.
Okay, thank you, sir.
Okay.
Good night, sir.
Bye bye. I
Good
can
night,
end
everyone.
the session. Yeah. The
Yes, sir.
session is
Thank
over.
you.
Bye bye.